All right, so for video 7, we're going to be talking about momentum, which we already covered in the previous video, where P equals mv. P is momentum, mass times velocity is momentum. And then we're also going to be talking about kinetic energy, which is referenced as Ke. So let's start off with energy. So there's 3 forms: potential energy, kinetic energy, and then gravitational energy. Kinetic energy is written as 1/2 mv squared. Potential energy is written as 1/2 kx squared. K is the constant of the spring. And then lastly, gravitational is just mgh. So energy is always conserved, so therefore 1/2 mass velocity squared, where it's the initial velocity plus 1/2 kx squared initial x plus mgh initial h has to always equal 1/2 mv final velocity squared plus 1/2 kx x final squared plus mgh final. So this is really important to remember. Also, momentum is always conserved in a closed system. So as long as there are no external factors affecting the object that we are looking at, then momentum would always be conserved. So let's see how this applies in a problem. So here we have a track. Two carts with one spring, and this is moving towards the spring. Let's call this one A and this one B. Now we know that momentum is conserved since we are assuming that this is a closed system. Oh wait, firstly we need to talk about what happens after they collide. So B is at rest. So therefore, the second figure would look something like this, where this is the track. B would move outwards here, and then A would move in the opposite direction. So here we see it's coming at, since it's a closed system, we know that momentum stays the same, so conserved. However, kinetic energy, there's a change in kinetic energy. Here we just have 1/2 mv squared. We can ignore potential energy for cart A and also gravitational energy. So here, however, we have potential energy as the spring. So when these two collide, when the carts move in opposite directions, the spring exerts some more force here, so, and it also exerts here. So therefore, when these two collide and go into their separate ways, since some of the kinetic energy was, some of the potential energy was transferred into kinetic energy, that means kinetic energy would increase. So in this case, for question 7, that'd be option B.